What happens to a human body that dies in space? An exploration of decomposition in the vacuum of space. The vastness of outer space presents an environment unlike any on Earth. Its vacuum, extreme temperatures, and lack of atmosphere create conditions that are not only inhospitable to life, but also alter the processes of death and decomposition. In this research, we will explore what happens to a human body that dies in space, focusing on the mechanisms of decomposition and the unique variables of this alien environment. Point 1. Understanding decomposition on Earth. To understand what happens in space, it's important to first review how decomposition occurs on Earth. After death, the body undergoes the following key stages. A. Autolysis, self-digestion. Within minutes to hours after death, cells lose oxygen, and enzymes begin to break down cell membranes. This process leads to the release of fluids and gases. B. Putrefaction. A bacteria in the body, particularly in the intestines, proliferate and break down tissues, releasing gases like methane and hydrogen sulfide. This stage is responsible for the bloating and odor commonly associated with decomposition. C. External factors. Environmental conditions, such as temperature, oxygen levels, and microbial activity, play a critical role in how quickly a body decomposes. Point 2. The unique environment of space. Space is vastly different from Earth, and these environmental differences significantly affect the process of decomposition. The key factors in space include vacuum. A space is a vacuum, meaning there is no air, no oxygen, and no atmospheric pressure. This eliminates microbial activity that depends on oxygen for survival. Extreme temperatures. Temperatures in space can vary drastically depending on exposure to sunlight. Objects in direct sunlight can reach over 120 degrees, 248 degrees, while those in shadow can drop to 270 degrees, 454 degrees. Radiation. A space is flooded with cosmic radiation and ultraviolet UV rays, which can destroy cellular structures and DNA over time. Microgravity. In microgravity environments, bodily fluids and gases behave differently, potentially affecting internal pressure and the movement of decomposing substances. Point 3. Immediate effects of death in space. If a human body were to die in space, the immediate effects would depend on whether the body was in a spacesuit or exposed directly to the vacuum of space. A. In a spacesuit. Fact: oxygen depletion. The body would die from asphyxiation or other causes depending on the situation. Sealed environment. A spacesuit might temporarily slow down decomposition by creating a sealed environment where internal bacteria can still thrive. B. Exposed to the vacuum. Fact: rapid decompression. If a body is exposed to the vacuum of space, the lack of atmospheric pressure would cause bodily fluids to boil and vaporize due to reduced boiling points. This process is known as ebulism. Fact: freezing. Simultaneously, the body would rapidly cool in shadowed areas, potentially freezing solid. However, freezing is not instantaneous due to the low density of heat transfer in a vacuum. Point 4. Does decomposition occur in space? Decomposition, as we know it on Earth, depends heavily on microbial activity, oxygen, and environmental conditions. In space, these factors are significantly altered. Fact: absence of microbial activity. In the vacuum of space, most Earth-based bacteria would not survive due to the lack of oxygen, pressure, and protection from radiation. Without microbes, the typical putrefaction process would not occur. Physical changes to the body. Fact 1. Desiccation, drying out. In the vacuum of space, bodily fluids would vaporize and sublimate, leaving the body mummified rather than decomposed. Fact 2. Radiation damage. Over time, high-energy cosmic radiation would break down cellular structures, causing the body to deteriorate at a molecular level. Fact 3. Freezing and preservation. If the body remains in a cold, shadowed region, it could be preserved for millions of years. similar to how ancient organisms are preserved in ice on Earth. Fact 4. Decomposition. Inside a spacesuit. If the body is inside a spacesuit, decomposition might still occur in a limited manner. The sealed environment might trap heat and allow anaerobic bacteria, those that don't require oxygen, to break down tissues, producing gases that could cause bloating. However, once the spacesuit fails, the body would be exposed to the vacuum, halting further decomposition. Point 5. Long-term fate of a body in space. The long-term fate of a body in space depends on its environment. Fact 1. Drifting in space. The body might remain mummified and gradually deteriorate due to radiation and micrometeoroid impacts. Fact 2. On a celestial body. If the body lands on a planet or moon with extreme conditions, e.g., Mars, the moon, it could be partially preserved or eroded by local environmental factors. Point 6. Real-world examples and hypothetical scenarios. While there are no known cases of human bodies decomposing in space, certain scientific experiments and analogies provide insight. A. Tardigrades and microbial survival. Research on extremophiles shows that some life forms can survive in space temporarily, though human-associated bacteria would likely perish. B. Frozen astronauts. Fictional scenarios, such as in movies, often depict frozen bodies in space, which aligns with the likelihood of freezing in shadowed environments. Point 7. Conclusion. What would happen? A human body that dies in space would not decompose in the traditional sense. Instead, 1. In the vacuum, it would undergo immediate physical changes, such as desiccation and freezing. 2. Without microbial activity, the body would likely mummify. 3. In a spacesuit, limited decomposition could occur due to trapped anaerobic bacteria, but this would stop once the spacesuit fails. Over time, the body would be subjected to cosmic radiation, extreme temperatures, and micrometeoroid impacts, causing gradual molecular and structural deterioration. This unique and alien process highlights the strange and fascinating nature of space, where even death takes on forms unlike anything on Earth. Like what you saw? Smash the like button, subscribe for more deep dives, science, mystery, and the unknown. And hit that bell to never miss a story.